So these first couple of things we're doing are looking at bullet points 1, 3, and 4. All right. So if we're just looking at number 1 right here, this is like bullet point 1. Who sees a problem on here that they can do? You can do A. Great. How about let's rephrase. Are there any on that list of A through L or M, or excuse me, that you're not sure about? I'm seeing back row squinting, so I'll make that a little bigger. How about H? Are we sure what to do for H? Say it loud, Geraldine, so everybody can hear. So Geraldine says that you need to FOIL that out first, and then we can just use our general antiderivative rules afterwards. Everybody's cool there? How about M? What are we going to have to do for M? Good. And then we can reduce and then rewrite them with negative exponents. Should be easy from there, right? Notice that I haven't completed any of these though, right? Okay. What does your completed answer need to make sure it has? Plus C at the end. You guys feel good on this kind of problem? Okay. What about problem 2? Yeah. And in fact, there's a couple on here that you guys have no idea how to do by hand, and you'd have to do it on your calculator. So B is an exponential function. We have no idea how to do the integral or the antiderivative or derivative of a exponential function. Must be done with the calculator. D has an absolute value function. Even though it's polynomial on the inside, the absolute value is like a whole different animal. You'd have to do that on your calculator. And then E, remember that that our antiderivative rule that we have doesn't work for an exponent of -1, which is what you have with the 1 over x there. Does anybody remember what I told you that antiderivative of 1 over x is? It's the natural log, yeah. Now, would not expect you to do it by hand. That's a calculator problem. You guys cool on how to get the stuff into your calculator? Mm-hmm. Yeah, we'll do both those two things. So I'll do like Luca, let's say we do D on the calculator. Sound good? So I'll start by pressing math and then command 9 that says fn int. And then I'm just going to try to type this in exactly the way it looks like on my sheet of paper. So my bounds were -3 to +3. To get the absolute value, I'm going to press math and go over to the number tab and then pick ABS for absolute value. And I'll just type in my function just like it looks like on my sheet of paper. Add in the x for my dx and press enter. And there's my answer. Bada boom! Sound good there? Okay. And then Joey, you wanted to do part A here by hand. So the first step would be to do the antiderivative. So for the first term, that'll be 3t cubed over 3 plus 2t squared over 2 plus 5t. And then we have to evaluate that from -2 to +2, right? So far, so good? So those will reduce out of there. Let's do that. So we're going to have 2 cubed plus 2 squared plus 5 times 2 minus, and then I have to make sure I'm subtracting the whole thing, -2 cubed plus -2 squared plus 5 times -2. So I have 8 plus 4 plus 10, that's 22. And I have minus a -8 minus a +4 and then minus a -10. So that's going to be 30, 40 minus 4, so 36. All right. Okay. Here it says use the graph of f of x to find the given integrals. And it tells us in the directions the curved segment is a circular arc. So the first integral they want us to look at is from -5 to -2. So there's -5, and here's -2. So what shape is that? A rectangle. What is the area formula for rectangle? Length times width, right? So this side is 6, that side is 3, so this area is 18. So we're done, right? The next one is from -2 to 0. So -2 to 0. What shape is that? Trapezoid, or you could break it up into a triangle plus a rectangle. Either is fine. The area formula for trapezoid is 1/2 base 1 plus base 2 times the height. So 6, 3, and 2. So 6 plus 3 is 9, times 1/2 is 9 over 2, and then times height, which is 2, that just gives me 9. The sum of the two bases divide by 2 times the height, which is 2. So far so good. 0 to 3 is here. So that looks like what shape? Looks like a quarter of a circle to me. Do you guys agree? Looks like the radius of that circle is 3. So like 9 pi over 4. What do you think? So far, so good? Should be no big deal, right? Yes. And the next one is from 3 to 5. So what shape do we have there? It's a triangle, which is 1/2 base times height. So 1/2 of 2 times 2. And then the last one is the integral from -5 to +5. Well, that should just be the sum of those 4 areas that we just did. What do you think? No big deal, I hopes, right? All right. Let's do a couple more examples of stuff, and I'll leave you guys to kind of doing your own thing here. Sound good? So here's an example of a story problem, right? These are probably the hardest ones that we ask you to do here. So it says fuel tank A is filling from fuel tank B at a rate of dV dt equals 3 minus 0.1 t, where t is in seconds, and dV dt is in liters per second. I'm guessing that's supposed to be a lowercase l because we're talking about a volume. So part A says write down an integral expression for the volume of the fuel tank A after t seconds. Well, I know that volume is just going to be the integral of dV dt with respect to time, right? Everybody's okay with that? That to get a volume, we integrate a rate. So dV dt we know is 3 minus 0.1 t. And I want to look at something real quick. On how they wrote this final answer. I have a feeling I know what they're going to do here, but I just don't want to like it. Yeah, okay, so that's the dumbest thing I've ever seen. That looks good then. All right. I was afraid that's what they're going to do, but that's fine. I would say from a calculus teacher standpoint, this is still wrong, but whatever. Yeah. Because it's not a function. I would say that the way you should write this is Should write it like that. So now it's a function of t, where it's going to give you the volume at some time t, but whatever. Anyways, I had a feeling that's the way they're going to write it. It says then part B, find the volume of fuel transferred to fuel tank A from fuel tank B for the first 10 seconds of filling. So it wants a volume, right? So we should be using our volume function. And since it's the first 10 seconds, that means we're going from time 0 to 10. Everybody feel okay with how I put that together? Now to find the actual value here, what could I do? I could use my calculator to do that. Let's do that. Colin, I see yours is already out. Will you tell us what we get here? Thanks. Cool. And those would be liters. Fuel tank A has a capacity of 40 liters. Find the time when fuel tank A will be full. Again, I would say read question C. I would say there's not enough information to complete this problem, but I'm sure that they did anyway by making an assumption that is not here. Read that and see if anybody can tell me what the missing assumption is. Yeah. Yeah, so you could do it a couple of different ways. What I would probably say is the easiest way of doing this is I would just do, oops. I would do that and then just set it equal to 40. Or you could graph on your calculator with 40 and find the intersection. But this is a pretty easy thing to solve. But why is Mr. Kulik saying there's really not enough information to really answer this question, even though this is what they're expecting you to do? They didn't tell you how much fuel is in tank A to start, right? It just says fuel is being transferred from tank A to tank B. It doesn't tell you it's empty. The tank A is empty. It doesn't tell you how much fuel is in tank A to start with. What if it was already full? You know, like it's an incomplete question as far as I'm concerned. Textbook did a poor job of editing itself once again. So if I solve this then, again, I could do this several ways. I mean, you can do that. And then 40. Now we're going to have to change our window here. I know it's going to be more than 10 seconds because we only get to 25 liters in 10 seconds. So I'm going to make my X max, I don't know, like 30 seconds or something. Should definitely get there by then. And then my Y is, I'm fine with that being a negative, but my max needs to be at least 40. I'm going to go up to 50, I guess. But this should do it. The only downside here is this is kind of slow graphing, but we got time. Looks like 20 seconds to me. So far, so good? Part D says after fuel tank A is filled or is full, fuel tank B is then used to fill fuel tank C. When dV/dt is equal to 0, there is no more fuel in tank B. Find the time when that occurs. Well, it tells us we need to solve for dV/dt is equal to 0. So when I do that, I get 30 seconds. So far, so good. So for part 2, it says then find the number of liters in fuel tank B before filling fuel tank A. So there's two ways I could do this. I could do 40 plus the integral from 20 to 30 of that dV/dt. Or I could do the integral from 0 to 30 of dV/dt. Either one should give me the same result. Because I know this is how much we put into tank A, right? That took 20 seconds to get there. I know we're empty at 30 seconds, so whatever I fill from 20 to 30, then I would have to add to 40, and that'll do it. Or I could just go the integral from 0 to 30. Either one will give me the same result. What do you guys think? Is that okay? So you could do it either way. So I knew it took 20 seconds to fill up tank A to 40 liters, Joey. So anything after 20 seconds then is going to go into the other tank. What do you guys think? Another one of these guys? Are these the worst ones? Let's try that. The Red Chair Company. I wonder what they sell. Sells N red chairs per month. The marginal profit in GBP, I think that's probably Great British Pounds, would be my guess. Is that what that stands for? Can be modeled by the function dp/dn equals 300 minus 3n. Find the number of chairs that should be sold to maximize profit. Well, we don't have the function p, right? P would be profit. What we have is dp dn. So how are we going to find the maximum then? We're going to find the critical values for the function by setting the derivative equal to 0. So that gives me n is equal to 100. Is okay there? Now that's not enough to tell me it's a maximum, right? All that tells me is that it's a stationary point or a critical value. To show that it's a maximum, what I would do is a second derivative test. So the derivative of 300 minus 3n is just negative 3, correct? Since that's less than 0 when n is equal to 100, in fact, it's less than 0 for all n. I know that this guy is a maximum. Is everybody okay with that? You could have done a first derivative test too and drawn your sign diagram, but like that's second derivative is so easy there. Just like way less work, right? And you have to plug anything in because the second derivative is negative everywhere. All right. It says the profit from the sale of 40 chairs is 500 pounds. Find P of n. So it's asking us to find P of n when P of 40 is 5,000. Well, P of n is just going to be the integral of my dp dn So I have that, right? This part is going to be given to me to solve for C. So that gives me C is negative 4,600. Feel okay there? Part I says to calculate the profit from selling 80 chairs. Well, I just need to plug 80 into that guy. So that's $9,800. So part I asks to find the least number of chairs that must be sold in order to make a profit. So when is there a profit? When the profit is greater than 0, right? So all I'm going to do is to solve P of n equal to 0. Now I could do that by hand, it's a quadratic, or I could just graph it on my calculator and find the 0. That's probably what I'm going to do. Or I could use the quadratic formula, whatever, like bunch of ways I could do that. Now, I know from given information that that number of chairs has to be less than what value? If I look, I know that 40 chairs made a $5,000 profit, so there's no way that n can be bigger than 40, right? So that's nice that I have that, as it'll just create an upper bound when I make my window here. So my x's are my n's. I'll just go there, and I'll just go like negative 1,000 to positive 1,000 or something. Should be enough to see nicely any profit, or see that profit function crossing the x-axis. There it goes. So I just need to find that 0. So left bound, right bound, guess. So 16.7 but we're talking about chairs. Can I sell 0.7 of a chair? Nope. So what should I round that to? Should I round down to 16 or up to 17? Up. Because if I sell less than 16, or if I sell less than 16.7 shares, I'll be negative. Won't be making a profit. If I round up, it'll be above, so it will be profit. So I'll do that. And then part IV asks for the maximum profit. Well, I know that. I know when that happens. When does that happen? When I sell 100 chairs. So all I need to do is plug 100 into n and get my number, whatever that is. I don't care. What do you guys think? Feels okay? Let me look at, do we remember how to do the trapezoid rule? No. Ugh. They're just adding up a bunch of trapezoids. Yeah, I mean, sure. All right, I'm just going to do part A of this problem. So it says, use the trapezoid rule to find the total distance traveled by the car. Okay, so I'm going to use the table here. So I'm going to form one trapezoid with that part of my table, another trapezoid from that part, another trapezoid from that part, and my final trapezoid from that part. Everybody okay with that setup? So these numbers are going to be my bases, and my delta t is going to be my heights. So my first trapezoid is going to be 1/2 of, hi, Miss Lytle. He's absent. Oh, no, he did come in. That shows what I'm observing I've been. Ollie, it's for you. And then my height is 1 because there's a change of 1 in my x values, or in this case, I guess, t's, in my independent variables. So the next trapezoid is going to be 24 plus 19.5 times 1. My next trapezoid is going to be 1/2 19.5 plus 9.6, and now it's times 2. Notice in the blue circle the t is changing from 2 to 4. And then my last trapezoid is going to be 1/2 9.6 plus 0 times 2. And I just add them up. Does that feel okay there? Okay. Should be pretty easy. I think the only thing we haven't talked specifically about yet is finding the area between two curves. Do you remember how to do that? So let's say we have two curves like this. Everybody's okay? So I got two curves. First thing I'm going to do is find the intersections of them. I'm going to call that intersection A and that intersection B. Everybody feel good there? And this spot here is what we're finding, right? The area between the two. So that area is going to be the integral from A to B of the function on top minus the function on bottom. Which function is on top, f or g? F, right? And g of x is on bottom. And then just into my calculator she goes. Well, those are the x values of the intersections of the two curves. You look at the picture. So if I look at this region, the red curve is on top, so that's f of x. Is that what you're asking? Or are you asking about the a's and b's? I'm checking the integral. So the A and B, because A comes before B on the number line? if it was the first intersection was B and then the second intersection A, it would be from B to A instead of A to B. It's just like whichever number is smaller. Does that feel good? So that's the setup. I didn't do a specific example of that, but like, if you can set it up, you can do it if you can integrate things, right? Either by hand or with your calculator. I don't suspect this should be too bad. And this feels like enough talking for me today. What do you guys think? Feel adequately reviewed? Okay, now write down the integral expression for the car. Sure. And the ds dt is just given to me in the previous part. Sure. I'm guessing they gave you that so that like, that this is like ds dt when t is equal to 0. This number over here is ds dt when t equals 1. Just so you can like get into your calculator maybe in a more compact fashion, but you didn't need that piece because they gave you the table. I don't know why they gave you both in the part A. I think that's confusing, but that's what they did. You feel good on that, Anna?